this is the concept of microgrid, in which we have to need few challenges is there. Okay, now also in few challenges are voltage stabilization, power management, power quality management, protection, grid integration, stability issue, and last one is the SLAN operation. These are the few challenges in microgrid. Also, these few challenges of microgrid, it will depends on R&D need. It is research and development need. Also, this R&D concept classified into several points. First one is the design of microgrid architecture. It is very important. And also, in which we have to need AC versus DC microgrid is here. Okay. Then also in which we have to need converter technology is here. In converter technology, we have to need several parameters like control architecture. It is very important is here. Then also in which we have to need MPPT scheme. Okay, this is the R&D data is here. Also in which we have to need adaptive and fast protection scheme is there. Okay, this is the very important scheme. It will be needful in microgrid concept. Okay, then also in which we have to need this SLAN detection and management scheme. It is very important. Then also in which we have to need smart inverter and converter. It is inverter means DC to AC converter, and converter means AC to DC converter and DC to AC converter. Okay, with network control features. Okay, then also in which we have to need virtual inertia generation is there, and last point is micro energy management system. These are the important needs in R&D data. Okay, now this is the important concept is here, that is few challenges and R&D need. Okay, then we have to explain several factors. It is very important in microgrid is here, that is major cost component in microgrid. Okay, these are the 5 component is here. This is the first component, second component, third component, fourth component, and fifth component is here. Okay, then also in which we have to need energy resources, that is 30 to 40% is here. Then in which we have to need energy storage, controllable loads, distribution generation, and renewable generation sources. These are the important energy sources used in microgrid. Okay, then also in which we have to need switchgear protection and transport. Okay, in which we have to need 20% of switchgear protection and transport. Okay, then also in switchgear protection we have to need utility interconnection. Okay, that is low cost switches, interconnection study, protection, and last one is the we have to need protection study for switchgear equipment, and also we have to need protection and transport. Okay, then this is the second component is here. Then third component is smart grid communication and control. That is we have to need 10 to 20% using smart grid connection and controller. Okay, then in which we have to need standard concept, protocol, then control, then protection technology. Then also in which we have to need real-time signal. It is very important in microgrid. Okay, that is we have to need local SCADA access. That is local SCADA access means supervisory control and data acquisition. This is the important things in microgrid. Also in which we have to need power electronics converter, that is called as smart inverter. Okay, this is the important concept of smart grid communication and controls. Okay, then also we have to need fourth component is site engineering and construction, that is 30%. Okay, then also in which we have to need system design and analysis. system integration, testing and validation. Okay, now this is the important site engineering construction required for microgrid. And last one is the operation and market. Okay, in operation and market we have to need outage management system. It is very important in microgrid for market utility and acceptance. Okay, these are the several major cost components required for microgrid. Okay, now this is the important concept is here. That is important components in microgrid. Okay, now this is the microgrid concept is here, and this microgrid concept classified into two types, that is AC microgrid and DC microgrid is here. Then in which we have to need, in AC microgrid we have to need 415 volt. In DC microgrid we have to need 750 volt is here. Okay, now this is the comparison between AC microgrid and DC microgrid. Then also in microgrid, in which we have to need several sources and storage. It is very important in microgrid. Okay, now this is the AC concept is here, and this is the DC concept is here. Okay, now here AC generation system is here, and also in which we have to use transformer. Okay, now this transformer is connected to the AC microgrid. Okay, now this is the switch, act as a static switch. It act as open or close the switch. It is connected to the utility grid and AC load is here. Okay, now also in which we have to need important things is DC generation, and this DC generated is connected to the 3-phase voltage source inverter. What is the function of inverter? It converts DC to AC supply. Okay, now this 3-phase inverter is connected to the AC microgrid, also in which we have to need converter. That is converter, it acts as a AC to DC converter. That is in which we have to need DC load is here. Okay, then also we have to need converter like buck converter, that is DC to DC converter is here. Now here this is the DC load is connected across converter, is shown in figure. Okay, and last one is the energy storage system. This energy storage system can be controlled with the help of energy storage control unit, and also in which we have to need bidirectional 3-phase voltage source converter, and this bidirectional 3-phase voltage source converter is connected to the static switch, and this static switch acts as a, when switch is closed, then energy flowing from source to load side. Then static switch is open, the energy does not flow from source to load. Okay, this is the concept of AC microgrid. Okay, now here also in which we have to need DC microgrid concept. Okay, now in DC microgrid we have to need AC generation is here. Okay, this AC generation is connected to the 3-phase voltage source converter or rectifier. Okay, now this is the rectifier convert AC to DC. Also this is the DC microgrid is here, and 3-phase voltage source inverter, it is convert DC to AC, and this AC supply is connected to the utility grid, and 3-phase AC load is here. Okay, now also in which we have to need DC generation, and this DC generation is connected to the boost converter, that is DC to DC boost converter. That is, what is the meaning of boost converter, that is output voltage is greater than input voltage, is called as boost converter. Also this boost converter is connected to the single phase voltage control voltage source inverter, that is here AC load is here. Okay, now this is the concept of DC generation. Okay, now in which we have need energy storage system. This energy storage system can be controlled with the help of energy storage control unit. Okay, now this energy storage control unit is connected to the bidirectional DC to DC converter. Okay, now what this is the output of converter is here, and also in which we have to need static switch, and static switch is here. The main function of static switch, it close, then energy flow from source to load. Then static switch is open, the energy does not flow from source to load, is called as working of static switch. Also next is DC to DC buck converter. Okay, so what is the meaning of buck converter? The output voltage of buck converter is less than input voltage or input side, then this type of converter is called as DC to DC buck converter, and this buck converter is connected to the DC load. Okay, this is the difference between AC microgrid and DC microgrid is here. Okay, now this is the Indian power sector management is here. The Indian power sector management is classified into three types. That is, first is the authorities, that is CAA and RPC, then R&D training section. Okay, and then Indian power sector management, also in which we have to need central sector organization, and also in which we have to need generation, transmission, also in which we have to need system operation, also we have to need finance and rural electrification. Okay, now this whole central can be controlled with the help of central government. Okay, then also in which we have to need state government, and the main working of state government is control state sector and state IPPs, that is Indian power sector. Then state sector classified into three types. First one is the generation, transmission and distribution, and this whole system can be controlled with the help of DISCOM. Okay, and this is the concept of Indian power sector management is here, and now this is the phenomenon of Indian power sector management is here. Okay, and this is the important thing is here. Okay, then here we have to need status of Indian power sector, and this status of Indian power sector, it can be controlled by installed capacity. Okay, this is the total installed capacity of renewable energy sources, that is 78.317 gigawatt is here. Okay, now here wind energy is 35,625 megawatt, then small hydro power is here, then biopower, in which we have need biomass classification and biogas, then waste to power is here, then photovoltaic cell power is here, and off-grid power is here. Okay, now this is the important thing is here. Then these are the important materials like coal, hydro, nuclear, diesel, gas, and renewable energy sources. These are the status of Indian power sector. It can be controlled in which we have to need month like February, March 2019. Okay, now this is the important thing is here. This is the status of Indian power sector. Okay. Okay, next point is power situation in April 2018 and February 2019. Okay, now here we have to need first point is energy and second point is peak demand. Okay, the several values are there, but in consumption of electricity we have to need rural electrification. It is very important. Then all India losses can be controlled and transmission and distribution losses can be controlled. It is very important for consumption of electricity. Now this is the exact power situation in 2018 and 2019. Okay, now this is the map of Indian in 5 region is here. Okay, now these are the region is here, then these are the installed capacity in megawatt is here. Okay, now here these are the renewable energy sources is here. This is the north region, then this is the west region, south region and east region, and north east region is here, and last one is the island region is here. These are the several capacity is here. The first capacity is 765 to 800 kilowatt. Its range is 40,873. Then 400 kilowatt is here. Its range is 1,79,269. Okay. Then 220 kilovolt. Then its range is 1,74,841. Then HVDC transmission line, that is called as high voltage DC transmission line. Its range is 15,556. Okay, this is the concept of map of India in 5 regions. Okay, next point is project objective. Then project objective, it is very important concept, and this project objective is totally depends on generation, transmission and distribution, and this whole parameter can be controlled with the help of microgrid central control. Okay, now this is the important concept of microgrid, and this can be controlled with the help of several parameter is here, and then also in which we have to need distribution network, and this distribution network can be controlled with the help of microgrid. Okay, now these are several parameters important in microgrid. First one is the finalizing overall project management architecture is here. Then distribution system modeling and benchmark system development. This is the second point. Then third point is energy storage. Then microgrid and active distribution system. And fifth parameter is cyber security. Okay, then sixth parameter is DSO function and energy management is here. Then DSO market and regulatory issue is there. Then lab testing and validation. Then field demonstration. Then impact analysis, policy recommendation including social survey, and last one is the workforce development. These are the several important things will be depends on UI assist thing. It is very important in microgrid. Then this is the village microgrid single line diagram is here. Okay, in microgrid single line diagram, in which we have to need 3-phase smart meter is here. Then we have to need AC to DC, DC to AC converter. That is, we have to need inverter and converter is here. Then these are the circuit breaker is here. Then also in which we have to need photovoltaic cell. That is the main thing of photovoltaic cell. It converts solar energy in the form of electrical energy. This electrical energy in the form of DC. And this DC charge, it can be stored in battery bank. Okay, now this is the concept of PV array. Okay, now also in which we have to need biomass generation. Okay, and this biomass generation also generate energy. Then also in which we have to need photovoltaic array, and also we have to need battery bank to store energy in the form of DC. Okay, now also in which we have to need 3-phase smart meter. Okay, now this is the important concept, that is microgrid single line diagram using village. Okay, now this is the visit in December 2018 to finalize the site and apprise Gram Pradhan and ward member is here. Okay, now this is the semi-urban and urban microgrid pilot projects in IIT Kanpur, in which we have to need 2 lanes inside the campus, that is 32 lanes and 33. Then also in which we have to need houses. It can be controlled under the semi-urban pilot. Also in which we have to need photovoltaic cell. Then also in which we have to need energy storage system, and also we have to need electric vehicle charging station. It is very important. Then also in which we have to need smart meters. These smart meters can be controlled in the form of 2 feeders. Okay, now also in which we have to need energy meter. Also we have to need thermal storage system. It is very important. And this whole system can be controlled under the SCADA system. It is under supervisory control and data acquisition. This is the concept of SCADA system. Okay, now this is the just overview of the SCADA system is here. This whole system can be controlled by microgrid project. Okay, this is the just overview of the semi-urban and urban microgrid pilot projects inside by IIT Kanpur. Okay, now this is the IIT Kanpur communication network is there. Okay, now in which we have to need, this is the semi-urban concept is here. This is the urban concept is here. Okay, now this is the whole system can be controlled with the help of SCADA system and EMI monitoring. Okay, now this is the third part is rural electrification. This whole system can be controlled with the help of optical fiber communication, and this optical fiber communication can be controlled with the help of communication network, and also in which we have to need distribution system operator. Okay, now this is the concept of SCADA system. Then SCADA system can be controlled with the help of two-way communication network, and this is the whole concept of SCADA communication network. Then next point is Government of India, its new initiative, in which we have to need renewable energy management center is here. Then battery energy storage system is here. Then green energy corridor, it is very important. Then wide area monitoring protection and control system, it is very important in microgrid. Last one is the demand response and pilot projects. It is very important in microgrid. It is first we have to need renewable forecasting, SCADA system, regeneration. Then we have to need scheduling of renewable energy sources. Then also in which we have to need testing of different battery technology at grid level. Then integration of renewable resources. Then strong grid connection. It is very important in smart grid or microgrid. Also in which we have to need several parameters. It can be control the grid, and also in which we have to need advanced metering infrastructure, and also we have to need price incentive for demand side management. Okay, now these are the several government of India's new initiatives. Okay, now this is the renewable energy management center is here. Okay, now this is the then first one is the Rajasthan, Madhya Pradesh, Gujarat, Maharashtra, Karnataka, Andhra Pradesh, Tamil Nadu. These are the several renewable energy management center is here. Okay, this is the important concept is here. Then next point is microgrid. Okay, now this microgrid concept can be controlled with the help of main grid. Okay, now this is the main grid is here. Then this is the substation point is here. Then distribution point is here. Then load side is here. This is the generation side is here. Now this is the microgrid connect or disconnect point is here. And this is the single controllable entity. Now this is the total control system is here. It is microgrid is totally depends on generation, transmission and distribution is here. Okay, now this is the microgrid control system is here. Okay, now in microgrid control system we have to need energy sources and energy consuming devices, and also this whole system can be connected to the smart building, smart campus and smart communities is here. Then also in which we have to need utility connection or interconnection. Okay, now this is the just look like ring bus microgrid structure is here. Okay, now this is the storage system is here. Now this is the thermal energy storage system. This is the wind energy system. This is the photovoltaic cell energy system, and this is the solar energy system. These are the several energy system using microgrid. Okay, now this is the important concept of microgrid control center. Okay, now this is the energy storage system is here. It is here inverter that convert DC supply to AC supply. It is energy storage system. Then here wind power plant, it convert DC to AC supply. Then photovoltaic cell, it convert DC to AC supply. Then industrial residential load, that is it will depends on requirement. Okay, now this is the AC bus is here. Then this is the thermal power plant is here. Okay, now this is the whole system can be controlled with the help of microgrid control center. And this microgrid control center can be controlled with the help of primary and secondary control system. Okay, now this is the important concept of microgrid is here. Okay, now also in which we have to need applications of microgrid is here. Then first one is the energy storage system, that is voltage source converter is here. Then voltage source converter is connected to the industrial load. Then here utility grid is here. Then domestic load is here. Then other microgrid is here. Then electric vehicles. Then photovoltaic panel is here. Then this is the operate with the help of voltage source converter. Okay. Then voltage source converter is connected to the wind turbine. Okay. Now these are the applications of microgrid is here. Then what is the concept of microgrid? Then microgrid, it can be controlled several parameters like generator is here, wind turbine, photovoltaic modules, then also load, public grid, energy storage system and gas. This whole system can be controlled grid. Then this type of grid is called as microgrid, in which we have to need energy demand. The energy demand depends on electrical and combined electrical and thermal system. Then distributed energy resources, that is, we have to need renewable energy sources like wind turbine and solar photovoltaic cell. Then conventional resources like diesel and gas generator. Okay. Then energy storage system like electricity storage system, example batteries. Then thermal storage like hot water. Then energy conversion like power to gas and gas to liquid. And last one is the control system. It is very important. This control system can be controlled with the help of intelligent control system with system optimization. Now this is the concept of microgrid.